This lesson will focus on multiplying decimals, including decimals that have negative values in them. So again, we're going to look at the algorithm for this. So when you multiply decimals, you can multiply the numbers without their decimal points, just like normal. Then you want to count the total number of digits to the right of the decimal point and all of your factors combined. So you're going to find the total. Third, you'll place your decimal point so that your final product has the same number of digits to the right of its decimal. And then just last, check to make sure your answer is reasonable. And when I show you some real examples, we'll talk about that. Don't forget to look at your final sign and make sure if it's positive or negative as well. So here's an example. Negative 3.6 times 4.53. If I'm multiplying these, usually it's easier if you put the number with more digits on top. So I would probably write 4.53 times 3.6, and I'll deal with the signs at the end. I'll notice it's a negative times a positive, so my answer should be a negative. This works because multiplication is commutative. You're allowed to switch the order when you add. And then we're going to multiply this just as if it was 453 times 36, like there were no decimal points whatsoever. And we'll start off with multiplying the 6 by everything. So 6 times 3 is 18. Remember, you bring down your 8 and you carry the 1 up here. 5 times 6 you do is 30 and add that 1, 31. And then 6 times 4 is 24. Add that 3, 27. You can write that down. We can cross off this 3 and the 1, or maybe even better, I might take my eraser and get rid of them so they don't throw me off next time. And then I'm going to move on to my second digit, which is that 3, or really multiplying by 30. So since it's 30 and not 3, the value there, I'm going to put in a placeholder 0. And then 3 times 3 is 9. 3 times 5 is 15. Carry your 1. 3 times 4 is 12. Add the 1, 13. Okay, and then I'm going to add these digits straight down. So 8, and then 9 plus 1, 10. 7 plus 5 is 12. Add the 1, 13. 1 plus 2 plus 3 is 6, and bring down the 1. Okay, so I've got this number, 16308. So the rule says count the total number of decimals or digits to the right of the decimal. So this one had 2 digits, and this one has 1. So altogether there are 3 digits to the right of the decimal. So what you want to make sure is in your final answer you need 1, 2, 3 digits to the right of the decimal. So the decimal point should go here, and we should have 16.308. Now we said before my answer should be negative. So we should have negative 16.308 or negative 16 and 308 thousandths. Just do a little check in the problem here. If you have these numbers, one's a little bigger than 3 and one's a little bit bigger than 4. 3 times 4 is 12. Okay, your number should be more than 12 if we were ignoring the sign altogether. A 16 seems reasonable, but if you'd put your decimal somewhere else, like 163 or 1.63, that would seem really unreasonable. So that helps you make sure that your decimal is in the right spot. Okay, let's look at a tricky problem. I say this is tricky because 3 digit by 3 digit is kind of ugly. So negative 3.45 times negative 1.34, it's a negative times a negative, so it's going to be a positive. Okay, so remember those little smiley face guys. Okay, we'll multiply this out. So again, I'm going to write down the numbers without the sign, or without the decimal points. 345 times 134. And then I'm going to start my multiplication process. 4 times 5 is 20. 4 times 4 is 16. Add the 2, we get 18. 4 times 3 is 12. Add the 1, we get 13. Okay. Now when I move on to multiplying it by the 3, remember to add your placeholder 0. 3 times 5 is 15. 3 times 4 is 12. Add the 1, 13. 3 times 3 is 9. Add the 1, you get 10. Okay. And then when I move on to this 1, it's like multiplying by 100. I'm going to add 2 placeholder zeros. And then 345 times 1, I just know that's 345. So I'll just write that down without the total algorithm. I'm going to add these up. The right's all 0. 8 plus 5 is 13. 3 plus 3 is 6. Plus 5 is 11. Plus 1 is 12. 1 plus 1 plus 4 is 6. and 1 plus 3 is 4. So I get 46230. Again, I want to count my digits. So I have 2 digits here to the right of the decimal, 2 digits here to the right of the decimal. So I'm going to do 2 plus 2. I need 4 digits to the right of the decimal in my final product. 1, 2, 3, 4. I'm going to put it here. 4.6230. We would probably just write 4.623 since the 0 doesn't really add anything to my number. And it is a positive final answer. And again, just remember you're multiplying something that's near 3 by something that's near 1. You should get an answer near 3. So 4 makes sense. 46 would not make sense. 0.46 would not make sense. So this seems reasonable.